All right, today we're going to be working on formula sheet applications. Our objective is that we will be able to use the formula sheet to identify figures and determine the area and volume of two-dimensional and three-dimensional figures, including practical problems. So the first types of examples we're going to do is where we have to find something that's missing first. So just like last class, we're going to follow our three main steps. We said that the three steps were find the shape/formula on the formula sheet, determine the value of all the variables, and plug into the calculator. Step 2 is where we're going to have some more work today. It might not be given to us. We might have to do some calculations to find them first. So first we need to read the problem and find out which shape and which formula we're dealing with. So a tent in the shape of a right cone, so we're using a cone, is made with waterproof material. If the material is used for everything except the floor, that's telling us which formula. Approximately how many square meters of material will be needed. Since it says square meters, that's our hint that it's an area equation. So which type of area? Is it the space covering two dimensions? No, because a cone is not 2D, it's 3D. So it's either got to be surface area or lateral area. Lateral area is the one we want because we said just the sides, not the top or bottom. And when you're making a tent, we're just covering the sides. So we know that this means that we're dealing with lateral area. So we now need the formula for the lateral area of a cone. Let's look at our formula sheet. Here's our cone. The lateral area is pi r L. Well, the picture doesn't tell us what r is or what L is, because r is the distance here. And L is our slant height that goes down the side of the cone. So let's find R first. We know the diameter is 12. Well, the radius is half the diameter, so that would be 6. So we know the radius equals 6. Now, because if you look here, this forms a triangle, we can use the Pythagorean theorem to find L. So remember, c squared equals a squared plus b squared. And if you forget this, it's on the back of your formula sheet. So L squared equals 9 squared plus 6 squared. 9 squared plus 6 squared give you 117. So L squared. Then we got to square root both sides. And if we type the square root of 117 into our calculator, we get a decimal. So we're just going to leave it as L equals the square root of 117. Now that we've found R and L, we can put them in our formula. LA equals pi times 6 times the square root of 117. Let's put that in our calculator. Pi times 6 times the square root of 117. And we get 203.89. And we know our units are square meters. Example number 2. Find the surface area of a pyramid. So good, that tells us our formula and our shape, with a square base with side lengths of 6. So that means each side of the bottom is 6. I'm not going to write it in the back because it gets confusing. And a height of 4. So our height is 4, how tall it is. So our surface area formula. Here's our pyramid. Surface area is equal to 1/2 LP plus B. Now, it shows us that L is this length here. It doesn't have P labeled on the picture anywhere, and big B is just in the bottom here. If you forget what those stand for, look on your formula sheet. So it showed us L in the picture. P is the perimeter. Right there. And then big B stands for the area of the base. So we need the perimeter of the base and the area of the base. Now, what shape was our base? It's a square base. So we need to find the perimeter and the area of a square. That's also on your formula sheet. Here's our square. So the perimeter will equal 4 times the side, and the area of the base, area is S squared. Well, it told us the side lengths are 6. So perimeter equals 4 times 6, which is 24. And the base equals 6 squared, which is 36. So now we've got P and we've got B. We still need L that goes along the side, the slant of the triangle. Now, again, this would form a right triangle if we connect them. This would be a right triangle here, which is good, which means we can do the Pythagorean theorem, but we need this side down here first. Well, the height lands directly in the middle of the base. So if the side length of the base is 6, but we want to go from the middle to the outside, that'd be half of it, which would be 3. So L squared would equal 3 squared plus 4 squared. 3 squared plus 4 squared is 25. And if we square root both sides, we get that L is 5. Check. Now we have all 3 of our variables. So the surface area will equal 1/2 L, which is 5, times P, which is 24, plus big B, which we found to be 36. Type it all in our calculator. We get 1/2 times 5 times 24 plus 36. So it's 96. Everything was measured in feet. And since it's area, the units are squared. Now, what if we're given an area or a volume and we're asked to find a missing measurement? So in example number 3, a rectangular prism has a volume of 200. So that tells us our shape and our formula. If we look on our formula sheet, the volume is equal to length times width times height. So let's see what we know. The volume is 200 meters cubed, so I'm going to put in 200 for the volume. The length measures 8 meters, so 8 times the width measures 15 meters, what must be the height? So we know everything but height, so now we've got to solve for it. 8 times 15 gives us 120 each. Divide both sides by 120, and we get that the height is equal to 1.67, and our units for everything was meters. Example number 4. A cylinder, so there's our shape, has a lateral area. That tells us what formula to use. So the lateral area equals cylinder, lateral area is 2 pi RH. The lateral area is 40 pi feet squared. The height is 9. What is the diameter of the cylinder? So let's see what we got. Lateral area is 40 pi. Bring down the 2, bring down the pi. We weren't told what r was, and we have a height of 9. Well, if you recall, the radius is halfway across the circle, and diameter is the entire way across the circle. So if we know the radius, we can find the diameter. So let's find the radius first. Let's multiply what we can here. Since there's a pi over here, I'm not going to worry about the pi on the right yet. So 40 pi equals, I'm going to multiply the two numbers that I have together. 2 times 9 is 18 pi r. Since these are all being multiplied, I'm going to divide by 18 pi. Divide by 18 pi. The pi's would cancel out, and 40 divided by 18 is 2.22, which gives us the radius. But remember, we're trying to find the diameter. Diameter is equal to 2 times the radius, which, if you forget, never mind, I thought it was on here. It's not. JK. Diameter is twice the radius, so diameter equals 2 times 2.22, which means our diameter is 4.44, and we're measuring things in feet. That's all for today.